Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on September 23, 2025, which was about 3 days ago. The headline result is that training continuous soft and fuzzy chain of thought with reinforcement learning matches discrete pass at 1 while improving pass at 32, with examples like hard sampling at 96.8% versus soft or fuzzy sampling at 97.9%. The paper is titled Soft Tokens, Hard Truths, and the implications for model training are quite significant. This paper shows a scalable, low-overhead way to learn continuous thoughts that boost sampling diversity and keep base model behavior intact across out-of-domain tasks. Alright, the introduction set the motivation for continuous thought, and Figure 1 now maps how hard, fuzzy, and soft chains of thought flow through the model. The diagram shows tokens passing from the embedding layer up through the transformer, a linear layer, and into the softmax, which defines the next step distribution. The green box marks a very low temperature, so fuzzy tokens become near discrete. The purple block shows Gaussian noise added to soft embeddings, which makes the trajectory stochastic and trainable with reinforcement learning. Well, Figure 1 showed how soft and fuzzy thoughts are generated. Figure 2 shows training and validation success for Llama 3B on GSM 8K. The curves rise quickly and plateau near 85 to 90%, which indicates stable learning with all methods. The left panel tracks training success and reveals more noise for soft, consistent with exploration. The right panel shows validation success, where hard is slightly higher, while fuzzy stays close and soft trails modestly. So, while Figure 2 showed stable learning curves, Figure 3 reports hard inference pass at K across Llama models. The curves indicate that soft and fuzzy training push pass at 32 higher than hard training, which signals better sampling diversity. The triangles for greedy pass at 1 cluster tightly across methods, so top 1 accuracy stays comparable. The result matters because deployment can keep standard hard decoding, yet gain stronger pass at 32. So, while Figure 3 highlighted higher pass at 32 after continuous training, Table 1 summarizes the head-to-head results across models and datasets. The table shows greedy pass at 1 remains similar for all methods, whereas soft and fuzzy training lift pass at 32. For example, Llama 3B on GSM 8K reaches about 98 pass at 32 with soft training versus about 94 with hard. Llama 8B trained on GSM 8K generalizes to MATH 500, with greedy around 44 for soft and fuzzy, but only about 20 for hard. Alright, Table 2 shifts to out-of-domain behavior across Hellaswag, ARC, and MMLU. The table reports accuracy and the negative log likelihood of the correct answer, and it shows similar accuracy across training styles, while soft and fuzzy consistently lower negative log likelihood. The ARC columns highlight the clearest gap, which suggests a gentler touch on base capabilities, so the continuous training improves calibration without sacrificing accuracy. So Table 2 showed gentler out-of-domain behavior after continuous training. Figure 4 contrasts entropy profiles across chain of thought steps for greedy and sampled decoding. The overall grid shows that fuzzy and soft training largely preserve the base flat entropy, which means uncertainty stays stable as reasoning unfolds. The hard sample column highlights the exception. Without fine-tuning, entropy blows up, while hard training suppresses it strongly, suggesting overconfidence and reduced diversity. So while Figure 4 highlighted how uncertainty evolved during reasoning, Figure 5 tests robustness with 2 ablations. The left panel shows noise scale. Gamma near 0.1 in 1 reaches about 84% validation success, while gamma equals 3 collapses and drifts near 50%, which signals excessive exploration. The right panel varies temperature. Tau from 0.1 down to 0.001 all climb to roughly the same plateau, despite a brief dip for tau equals 0.1 that recovers quickly. These trends indicate wide training stability to reasonable noise and temperature choices. Alright, 2 takeaways stand out. Training with continuous soft or fuzzy chains of thought using reinforcement learning matches top 1 accuracy while reliably lifting pass at 32, and it preserves base behavior and calibration on out-of-domain tasks. The broader implication is simpler deployment with richer sampling. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.